What the heck happened to my camera? One sec. Okay, we good now? Why am I so off center? Wait, I pushed it the wrong way? Wait a minute. All right, it's still. I need to get that more sturdy mount. All right, how's it going, everybody? We have a cool new script. Supposedly, hypothetically, allegedly, we can just do this, and it sets up everything. That's pretty cool. Now I just need to actually read the problem. Yeah, it only took me, what, 16 days to finally feel motivated to write that script. 16 times I did it by hand. Then I finally had enough. Going good, having lunch. How have I been? I've been good. My schedule's all sorts of messed up, but other than that, can't complain. All right, let's do day 17. Clumsy Crucible. The lava starts flowing rapidly once the lava production facility is operational. As you leave, the reindeer offers you a parachute, allowing you to quickly reach Gear Island. As you descend, your bird's eye view of Gear Island reveals why you had trouble finding anyone on your way up. Half of Gear Island is empty, but the half below you is a giant factory city. You land near the gradually filling pool of lava at the base of your new lava fall. Oh, lava fall is pretty cool. Lava ducts will eventually carry the lava throughout the city, but to make use of it immediately, elves are loading it into large crucibles on wheels. The crucibles are top-heavy and pushed by hand. Unfortunately, the crucibles become very difficult to steer at high speeds, and so it can be hard to go in a straight line for very long. It took you a couple of years to write the same script. To get Desert Island the machine parts it needs as soon as possible, you'll need to find the best way to get the crucible from the lava pool to the machine parts factory. To do this, you need to minimize heat loss while choosing a route that doesn't require the crucible to go in a straight line for too long. Fortunately, the elves have a map that uses traffic patterns, ambient temperature, and hundreds of other parameters to calculate exactly how much heat loss can be expected for a crucible entering any particular city block. Oh no. Each city block is marked by a single digit that represents the amount of heat loss if the crucible enters that block. The starting point, the lava pool, is the top left city block. The destination, the machine parts factory, is the bottom right city block. Because it's very difficult to keep the top heavy crucible going in a straight line for very long. It can move at most 3 blocks in a single direction before it must turn 90 degrees left or right. Oh, that's an interesting constraint. The crucible also can't reverse direction. After entering each city block, it may only turn left, continue straight, or turn right. Huh. How do you have the energy to stream and code this late at night? Because I woke up at like midnight. That's the problem with my schedule right now. Classic, I know. One way to minimize heat loss is this path. Eh. Eh. Uh-huh. Let me guess. Yeah. Gigantic. So this really is just like some sort of shortest path problem. We want the smallest numbers, but we have this weird constraint that we have to turn every so often. Your brute force is still running? Wait, are you just trying every path? I feel like that's not gonna work. Um, hmm. Oh, you're kidding? See, no, that's the sort of thing I would do though. Uh, I don't know how to do shortest path with this weird you have to turn rule. After entering each city block, it may only turn left. But why do I feel like you could still like go this way? What does this you can't reverse direction thing mean? Does it really mean you can never go like this direction or up? Because if we were here and we turned left, well, that's a bad example, but if we were here and we turned left, we could go up and then around like this. But would that technically be reversing direction? Oh, you can't go. Oh, I see. Reverse direction meaning like you can't. Why would you want to do that? That would never make sense. That would always be slower. Unless you were backtracking like one square. I don't know. Because part two. This is already a hard part one. I don't think we need a part two for this day. I think just one part sounds good for today. All right. We're shortest path on a grid. Does that mean we want A star? One major potential drawback is its O of B to the D space complexity. Oh yeah, totally. Whatever that means. Hmm. I don't remember how to do pathfinding. You thought this one was fun? I find it very annoying. Ooh, there's variants. We could do anytime A star, block A star. We could do D star. We could do uh lifelong planning A star. 24 hours of fishing. Oh god. No, we can't go 24 hours because then there would be a new problem and we would have to solve the new problem. We have at most like not that many hours. Is A-star? A-star's not uniform cost, is it? No, weighted graph. But Dijkstra's is uniform, I think. So we can't Dijkstra's here, I don't think. Oh no, wait. Shortest path between nodes in a weighted graph. I don't know. I thought uniform meant they all had the same weight. Do I look like a algorithms nerd? I probably do. Yes, no. Which I designed in about 20 minutes. Oh, nice. Impressive. Weird flex, but okay. I couldn't tell you what the difference between these two are in terms of well, Dijkstra's looks easier to implement. Can be viewed as a special case of A-star where h of x equals 0. What is h of x? It's O of edges? What are even our edges here? We got a lot of... There's a lot of edges. The heuristic? Stop making up words. A-star relies on a heuristic of how far your current node is from the goal. Oh, yeah, that's right. So Dijkstra's is more dumber than A-star. That makes sense. I don't even know if I could implement this in Bash. How am I going to do this? How is any of this going to work? We're screwed. I knew this day would come. Huh. This is definitely doable in Bash. Look how big this grid is. What kind of data structures are at your disposal in Bash? Not good ones. We have arrays and hash maps. We don't have 2D arrays. We just have regular ones. Hash map for the win. Yeah, you can technically make a 2D array with a hash map, but it's not very efficient. If you've got arrays, you might be okay. Yeah, hash maps can be 2D arrays if you glare hard enough. Yeah, we've already done that a few times for the other grid problems. Array of strings is annoying though, because then you gotta slice out individual characters from the strings. It's a pain. True. You know, a string could be a 2D array if you don't value your time. We just read this as one big string and then index into it. I'd prefer not to. All right, how does this work? What is reconstruct path doing? I don't know. Let's not worry about that until we get there. The set of discovered nodes that may need to be re-expanded. That's how I did my first 4 days of AOC before learning about vectors. Oh no. Open set equals start. It's usually implemented as a min heap or a priority queue. Yeah, let me just do that real quick. You know me. Bash is known for its priority queues. Okay, maybe we should just try Dijkstra's. How big is this grid? It's like 140 or something. It might be even taller. I don't know. We might have to do our curl thing. What is this? Day 17? Yeah, 141 by 141. Or 142 by 142, something like that. Oh, I'm scared. For each vertex. What's a vertex? Is that a cell in our grid? Vertex. And then the edges would be, you can go to here, or you can go to here. But then we need to keep track of how far you've gone. How many can you can go 3, right? So we need to keep track of how long it's been since you turned. No, but that doesn't work. Oh shit. Do we just add more connections? Do we say this one is connected to this one, and this one? And also that makes it have a lot of check the vault on your curl incident. Didn't have that specific issue, but on an early one, I found pasting into screen over SSH. What are you talking about? The problem was my copy paste. My terminal doesn't let you copy paste like a billion characters. Yeah, it gets cut off at a certain point. So yeah, we could do like the super connected graph, but then that's probably not good. I'll be honest, this seems hard. This seems really hard. Not even from the algorithmic standpoint. Like, okay, the algorithm part, sure, I could fiddle around on that for a while. but like I don't have a clue how to implement this in Bash. I just don't think anything we can do is gonna be fast enough. And I'm very worried. Hmm. You should be worried. Is indexing a 1D array slow in Bash? We could try doing it that way. So what, like, we say while file equals sample, while read line do done grid equals grid line echo grid. Okay, we have it in a 1D array, aka a string. And now you want to index it. You want to go like grid 15. It's definitely going to give you efficiency issues. Your Vim script took about 15 seconds to run. I don't know if Vim script would be faster than Bash. Also, you did this in Vim script? You're insane. The problem is that doing math in Bash is really slow. Which sounds dumb. I understand it sounds dumb, but it's a fact that we have to face. So if we're doing math to index this thing, it might be bad. So maybe it would be better to have this as an array, 1D array. So if we, let's think. Not designed to do complex math. I'm talking about arithmetic. This is not very complex math. Okay. I don't think we can do this, but bad substitution. So we'd have to do like row equals grid 1 and then index into the row. Okay. So we can do this for indexing. This should be pretty fast. But I literally, like, I don't even know what any of this means. Should we start with Dijkstra? Yes? All right. I mean, it's a lot shorter. We can get a sense of if it'll work. Graph and source. Okay. What why do they make these comments to paste? That's so annoying. Wait, what? Why didn't that work? I can just do this. Okay. Let's stretch this out. So for each vertex, what is a vertex in our case? Dist source. What is dist? I hate reading pseudocode. I know dist is distance. But what is what is this? This is an array? Dist source put a 0 into it? Like what the fuck does this mean? Dist is an array that contains the distances from the source to other vertices. From the source. Is the source the starting point? I guess. Source is 0 distance away from the source. True. That makes sense. And then we have a queue called Q, obviously. And while it's not empty, this syntax is infuriating. We like I hate that. Mathematicians are on drugs. We find the vertex in Q with the minimum dist U. Then we remove U from Q. Okay, so we're popping the one with minimum distance. You could just say that. After you do part 2, you write better pseudocode and update that website. Whatever. So this is initializing a bunch of shit to infinity. We don't really need to do this. We'll have a queue. Okay, add V to Q. What is... Okay, so we're marking every vertex as a place we want to visit. That's a lot of points. I don't think this is gonna work. How long will it take to brute force it? That's not even easier. Add V to Q. What is V? I don't know. V is the vertex. So what? We want like... $13 size. I less than size times size. Oh no, wait, we don't want to do that. We're gonna do 2 loops. Okay. R I have concerns. V equals row column. We put it in the queue. And you want me to put the distance to V to be infinity? Sure. Dist V equals... I don't have infinity. I have big number. Previous V... Okay, what's prev? Prev array contains pointers to previous hop nodes. Okay. We start by making it undefined. That's pretty easy. It already is. So dist 0, 0 equals 0. How easy. While the queue isn't empty, while the queue greater than 0. Nope, not then. Done. Okay. Looking good. We're gonna put
fatality.
Your queue there is gonna need to be a problem. Yeah. Yeah. It is gonna be a problem. I don't really have a plan there. Well, they all start with a distance of a really big number. Just dot sort. I don't think that would be a good implementation in any No, they start at big number. Thankfully, Bash has a wide array of data structures. We can check. There might be other ones that I don't know about, but I think this is all of them. Uh, Declare local and read-only built-ins, each except a -A option to specify an indexed array and a -A option to specify an associative array. If both options are supplied, -A takes precedence. Nope, that's all you get. Unless, wait, what are these? Eh. I mean, we just need to insert... We just need to maintain the sortedness. Right? It already starts sorted. Kind of. How hard could it be to implement a heap in Bash? I don't know. I'm sure you could implement one, but could you implement one that's fast? Yeah, let's start with just inserting it into the right position, and we can optimize later, maybe. You know, get a little binary search going. Oh boy. Okay, so we want the one with the minimum distance. So we'll say that one is at the front. So that's just u equals... Wait, how do you get the front item? Q0? And then I already forgot the syntax though, do a pop. But we did it in a different problem. Pop. Yeah, this. No. Not that. No. Wait. Didn't I do this? Okay, search item. Yeah, this. Pop from queue. For each neighbor v of u still in queue. What? Neighbor? How do I know if the neighbor is still in queue without just like scanning queue? This seems pretty, like it's not going to be very good. I'm just feeling so jaded about this problem right now. For each neighbor v of u still in Q. Wait, we never even push back into Q. So making it sorted is actually not even a thing. I think this pseudocode doesn't translate very well. All right, let me take a step back and see if there's anything we can do that's like faster. We could drop into a language that does have arrays like awk. Awk has arrays. Um we can see if somebody wrote. We can try and find a priority queue. Well, why is my Discord not on streamer mode? Sorry about that. Streamer mode. Who even pinged me? Oh, someone joined the Discord. Mm. Euclidean shortest path. That doesn't seem helpful. Bash priority queue. So when time to ask ChatGPT. Sure, if you think it'll help. How do I implement a priority queue in Bash? I need it to be fast and not fork. Let's see if it forks. This may not be the most efficient for large data sets. You might want to consider using a more suitable programming language. Yes. I will consider it. Make it efficient. Is this even right? I don't think this is right. That looks very wrong. ChatGPT would never be wrong. I think you and I have had very different experiences with this thing. Ask Bard. No. We can see if anybody's done Bash. Surely somebody's done Dijkstra. Oh, that's not a great idea. That's not a great idea. Infinity value, nice. Classic. So they just do a linear scan every time to find the minimum distance, which is pretty good. Yeah, it probably works great when you have a graph of this size. Dijkstra.awk. It's 1.8 kilobytes. What am I reading? So we can um we could try to get this working in awk. It might be the best we're gonna get. But how is this actually working? What the fuck is this? Solve, comma, number plus? What's their example input look like? Oh, this is example output. Oh, this is an input? Yeah, that ain't gonna work. You solved it without a priority queue or heap, but it did take a couple minutes. But was that in Python? Because if it takes a couple minutes in Python, that probably means a few hours in Bash. Yeah, that's not super feasible. Mm, if it works, it works. But I won't know if it works until I run it for like... These are not helpful suggestions. How many connections do we have? How many edges do we have? Everything is connected to like 4 others. So we have 20,000 vertices. I'd suggest making a file for each priority. I don't agree that that would be good. We only have 20,000 vertices. That's not that many. I don't know. Let's try with the linear scan and see where it gets us. Oh, but popping from the middle is kind of tricky. Okay. I think we just have to pop from the middle. Which is a pain. BitGolf Christmas update? What would that be? So first things first, we have to find the element. Big number. If Q QI is less than min, then let's pull this out. Min equals QI. Index equals I. So this should tell us where the smallest one is. So we can go to index. And then we have to pop our Q somehow. So we got the left-hand side is from 0 to index. 0 to index? Is it index minus 1? No. No, this is right. And right is from index to the ends, but it's index plus 1. Oops, what the fuck happened? Okay. And we need to combine these two arrays. I think we can just say Q equals left, and then Q plus equals right. Not sure how that works. Thanks for the follow. We can echo U. That sure is happening a lot of times. So I don't think it's actually getting removed. Echo left, right. Oh, why can't I kill it? Zero, 3. 3? That can't be right. How is it 3? We only put one thing into the queue. Oh no, wait, we don't. We put a lot of things into the queue. Oh, I see. Um, I don't think this is how you bash append to arrays. Yes. So we do left, right. I don't know why I took this countries. Q. Five, 0. That doesn't seem right. Index 3. Yeah, that doesn't make any sense. Index 0. Is it just running for a long time? I don't know. Let's let it run. There's no way. It's getting stuck. Why is index 3 for so long? So at some point, U stops being a thing. Okay, hold on. How long is the queue? The queue should be getting shorter. The queue is not getting shorter. How does it start out with a length of 3? What the fuck? Three? I feel like I'm going crazy. Oh, this is after we do this. It's still 3. All right. What is it out here? 3. It's not 3. You're lying. It's not 3. Look at all these things that are in the queue. Huh? Oh my god. It's that. I'm dumb. Alright, how long is the queue? I'm tilting. Okay, the queue is getting smaller. Does it ever stop? Okay, it gets down to 3 and then it just stays there. Hmm. Ten, 12, 11, 12, 12, 12. Oh, wait, is this a problem? No? This is wrong. Add array subscript. Right. Wait, but I thought dist was not an array. Line 41. We need a string. Uh, when we get to 5, 4, 3 is where it stops working. I think it's something to do with this popping. Let's try the unset Q index thing. I don't think that works, but yeah, no. Bash remove from middle of array. Unset then copy. Oh, interesting. Wait, is it not? This answer doesn't make any sense. Only just unset is not required in this case because unset is like, what are you saying? This is horrible. To remove an element and revive after that. Check who is offside. The fuck are you saying? We need a different thread. This is ridiculous. Yeah, this is what I was doing. Wait, was I not doing that? No, I'm doing that. I was literally doing this. We can try doing it all in one queue. What am I doing? Queue. Queue. Doesn't work. Because for some reason index is 3. Oh my god, it's this again. I hate this. Okay, it works. We're able to clear out the queue. Oh, jeez. I know. Why is my camera still like slightly off center? Driving me crazy. Now what? We need for each neighbor of V, for each neighbor of U still in queue. Maybe we keep a hash map of what's in queue. Because I don't know how else we do this. Queue map. Let's just call it wait, what? What's happening? So when we remove from the queue, we set queue map U equal to nothing. And up here, when we're initializing everything, queue map V equals 1. Sure. So we want to go to each neighbor. Let's get URUC. Or IFS equals comma. Okay. This is the position. So we want to loop over the 4 directions. For V in, I think you can just list them here. You can do like uh you are UC -1. You are UC +1. Do done echo V. Okay. These are the neighbors we'll visit. Oh geez. I guess we want the commas. So what does this say? Alt is distance plus graph.edges. Okay, yeah. So the distance to get to U. Dist U plus graph.edges is just it's the cost of moving into V. We can say udist and vdist is we gotta get the row. Grid VR. Vdist is grid. Oh, actually, can we do this all in one? I think we can. VC1. Echo udist plus vdist. That's a big number. I think we're not setting our... No, we are setting dist 0, 0 to 0. Oh, well, we're not updating the other dists. So we look at this for like the first few lines, it should be right. 4, 3, 3, 4. Yeah. So we need to say, what is this? Alt equals if alt is less than dist v, then dist v equals alt, and prev v equals u. Forgot a phi. Okay, it terminates. Now, what do we do with this information now that we have it? If we're only interested in a shortest path, we can terminate the search after line 10 if u equals target. Oh, interesting. After line 10. Now sequence S is the list of vertices constituting one of the shortest paths from source to target. Okay. Okay. Empty sequence. U is target. Okay. What's our target? It's the bottom right. So it's size -1. Size -1. If previous U is defined, or U is 0, 0, while U is defined. Okay. Oops. Do insert U at the beginning of S. Equals thanks for the follow. U equals preview. Keep forgetting little things. Just keep our comments here. Okay. Conditional binary operator. Eh? Oh, what is this? Okay. So in theory, U is now the shortest path. Or sequence is. So I print out the sequence. We go from 0, 0 to 0, 1 to 0, 2 to 0, 3 to 0, 4 to 0, 5. It looks like we're going straight across the top and then straight down. I'm not sure that's the, like, even not factoring in the fact that we don't make turns, is that the best path? I guess it probably would be. Okay. Now we need to factor in this part. I still don't know how to do this. Um, how do we prevent them from going more than 3 blocks? Do we just add more edges? That seems like a bad move. It would probably work. Although, no, because we still wouldn't know. I don't know how to do this part. uh, sure. You should cook some more. I've been cooking on this for the whole time and it never clicked. It's like I don't know how to factor it into what we have. Because it would be somewhere here instead of doing all of these. Okay. Because do we know while we're walking that we're on... I guess we could do like a look back. So right here, we could break, not break. We can continue if something is true. Um, So it would be 1, 2. What if we add metadata to this? That's like the direction. So this is, if we're going row -1, this is up. Row +1 is down. Column -1 is left. Oops. Yeah, I mean, it could be helpful. And if we bake it into here, we need to cut off. No, that didn't work. Hmm. Why doesn't that work? What have we broken? Oh, right. We're using V directly. So we need to set V back to VRVC. Okay. Okay, we've got our directions. Wait, 81 bad array subscript? Oh, oops. Sure. So we need to look back in the preview array. And if our directions are the same. Also, we need to get rid of some echoes. We have so many echoes going on. So if our direction is the same for too long in a row, then we just abort. up here. Good morning. So if look back 1 is the previous of U, then look back 2 would be the previous of look back 1 percent comma star. Is that legal? Can we do that? No. Okay, we gotta do that in 2 different steps. Hard fighting elf still doing AOC? Yeah. Something like that. Bad subscript on line 63. Excuse you. Oh, we have to check because we don't necessarily, yeah. We don't necessarily have an L1. I see why this is an issue. If L1, if it exists, then we do this. Oh boy. And then we go deeper. No, how are we getting bad array subscript? Oh, wait a minute. Bad array subscript 7, 12? Isn't prev an associative array? Shouldn't that be fine? Does it want like this? Oh, L2? Is that what I screwed up? Yeah. Doing it in bash? Yep. Unfortunately. It's causing a lot of pain today. Okay. So this will tell us D1 is this. D2 is this. D3 is this. And then we have to say if D equals D3 and D3 equals D2 and D2 equals D1, then continue. Does this work? Is this right? We go right, right, down. Right, right, up. Thanks for the follow. Is it not 3 lookbacks? Is it 4? No, because we have a run of 3 here. Why did we only go right, right instead of right, right, right? Uh-oh. Uh-oh. Oh, no. Wait. Right, right. Yeah, I think it's going up here. 1, 4. Oh, wait, it went up at 1, 4? Is that right? Row 1. Okay. 0, 1, 2, 3, 4. No, it still went up early. Yeah, yeah. Crap. What does it mean? Well, what's our metric here? The metric is how much heat we lose. So maybe it's just that there are multiple paths. Because it says one way to minimize heat loss. So maybe we just need to sum this up and it'll be right. How do we... Oh, I didn't think about how we were going to sum up the costs. I guess we can just take this path at the end and index into our grid for each one. For cell in do done echo cell. Yeah. We can do a read from the cell to get our row and column, and then we can do this echo row column. No? Echo equals. That's not what I wanted at all. We're still printing out a bunch of L1s. $112. Shit. 102. How do you figure? What do you mean it's getting there? It's not getting there at all. It's... Oh no. What was it before this? Okay, 80. So now we're overcooking. So we were finding a short path, but now we're finding not the shortest. I do wonder what happens if we add another layer to this. Uh, or maybe even if we just peel back a layer. Let's start by that. No, that gets us back to 80. Oh, wait. No. No, that gets us a higher number. Which makes sense, actually. Let's add another layer. D4. Woo! 101. Oh, you gotta be kidding me. How's it off by 1? Uh, try +1. I don't know why it would be +1 though. So we don't incur we don't incur the first one. So we need a if cell equals, well, it says unless we come back to it. So we just need to chop that one off. Right? Chop off the first one in the sequence. So we're actually off by more than 1. Can I check if it took the same path? I can, but like, I don't think there's only one path. I'm pretty convinced. So mine went right down, right up. Oh, and then it did 4 rights. Cheating. You can't do 4 rights. We do a little bit of cheating. Okay. So this was wrong. There's only one path with minimal cost. Is that real? We're sitting at 110 right now. The problem is, for some reason, hmm. Yeah, I wasn't relying on it, but if CodeMonk says there's only one, I trust. Right down. So why does it go up here? Why does it think that's a good move? Right down, right. So it goes up here because, presumably because 4 is less than 5? But that's not right. I wonder if this is the wrong place to do this check. Let's print out what it's skipping. So V. Skipping 04R. Skipping 16R. I don't see it ever skip the It's not skipping 1-5 because of the moving forward rule, but because of the immediate cost of that path. Right. But then how come they take it? Oh, wait. Yeah, so we're being too greedy with where we're... Is that right? Because it could be somewhere else down the line. Well, no. Well, what are we supposed to do instead? Like, I don't know where else we would enforce this rule. Like, the only other thing I can think of is creating more edges. Like, instead of... Right now we have, like... We have, like, this one is connected to this one and this one, right? We could connect this one to like here, here, and here, and then connect this one to here, there, and there. And then we just have to make sure that when we
Fatality.
make sure that we never go the same direction twice in a row. But that makes a lot more connections. That makes... You have 9 per location. Thanks for the bits. Also, I just realized we never do any bounds checking, and I don't know why it why that works. Maybe this is like implied 0 if it's out of bounds. I don't know. All right. Let's save this. Progress, I guess. And then let's start refactoring. So actually, no, it's only 6, right? Because you can't go immediately back the way you came, and you can't go the same way you went. So you only have 6 edges you can go to for any given case, I guess. What am I trying to do here? Uh,
Fatality.
how do I want to do this? So you can't go the same direction, but you just went in. You also can't go the opposite direction. Just make a bunch of conditions, like if D equals U and D1 equals D. It's so dumb. It's what 4 conditions will live. L R R L. Okay, we're sitting at 134. But that's because we never go the same direction twice. This code looks low level. Not really. I mean, it's pretty high level. It's just we don't have a lot of nice things that would be helpful here. Ah. Okay. So we can either move 1, 2, or 3. Oh, we have too many semicolons. All right, we got it down to 41. Nice. The problem now is that we're not correctly attributing the cost of the move. Because if we're moving multiple, we need to take the cost of the whole move. So how do we do that? Uh, how do we get the cost between two positions easily? For loop? Double for loop? We can set alt to udist for I don't know, some variable we haven't used. SR equals UR. I think you can do this. SR less than equal to VR. So now we go C. VDist is, or I guess this is SDist. Alt equals, we can do alt plus equals SDist. Can we use VDist anywhere else? No. 45. That doesn't seem right. Why is it 45? We go right twice. Wait a minute. Wait a minute. We're missing part of Dijkstra's in here. We never do if qmap v we're supposed to be doing that. Hold on. Let's try adding that back here. QMap V. Continue. Nah, we still get 110. That just makes it run faster, I think. Right? All right. How do you figure it's 45? I think your cost is... Oh, wait a minute. He figures it's 45 because this is doing dumb things down here now. Cur equals 0, 0. Uh, oh shit. Yeah, this doesn't work. Ah. Let's do R1 and R2. C2 and C1. And we need to say R1 equals UR, R2 equals, or, yeah, VR. And then the same thing for C. But then if this is if UR is greater than VR, else they need to be the other way. God. If only we had a min-max function, right? We have to do the same garbage down here. SRSC. Let's just keep these simple. Wait, what? Why don't we get a number? We get a whole lot of zeros. What are the zeros? So we're still printing out our sequence. Oh, wait a minute. I go UD. Wait, what? So we're still getting a path. Grr. Oh, UC. Wait, what's UV? URUC, VRVC. Yeah, we have all of our numbers. But for some reason, when it goes to print them out, it just doesn't do it. This loop like just doesn't run. Do I have these backwards? Is this less than? Oh my god. Okay. Okay, 195 is wrong. But I think we have the same bug up here. $150 is also wrong. Huh. So what is it saying we do? We move right from 0, 0 to 0, 2. Then we move down to 1, 2. Then we move right to 1, 5. 2, 3, 4, 5. Okay, good so far. Then we go up to here. Then we go right 3 times. We're on the right path so far. Then we go, what? Down 3 times? No, that's not right. I also don't trust this, like, counter. Yeah, we start at 0, 0. The cost is 0. We're here. We move to 0, 2, which costs us 7. That doesn't cost 7. What are you talking about? That costs 5. How does that cost 7? Is it counting 0, 0, 2? Yeah, I think it is. Shit, this loop doesn't work. Because it's inclusive, but it needs to be inclusive in one direction. Ah. Okay, what if we change these conditions? If UR is less than VR, then this is UR plus 1. Uh, if you are greater than VR, hey, how's it going? Haven't talked to you in a while. Thank you for the sub. Our last case here is that it's just VR. And just been busy. I know that feel. If it's greater than, we do this one plus 1. Sentimental. Okay, I think we need to copy paste this monstrosity up to here somewhere. Here. This is actually just awful. But it's okay. Because now it gets 226. Let's go. That's incredibly wrong. This is getting out of hand. I agree. What's wrong with this logic? Yeah, it doesn't get the right path because it's not calculating costs correctly. What does it think the cost from 0, 0 to 0, 1 is? 0, 0 to 0, wait, no, to 0, 1 is 4. Wait, it gets that right. Let's go. It costs 4 to get there. And then what does it do? It goes to 1, 2, which is 2 to the right. Wait, 0, 0 to 1, 0. No, that's not 4. 0, 0 to 1, 0 is 3. Wait, is it? Do I have my indexes backwards? How does it think that's 4? That's actually just 3. I don't understand how it got there. Maybe let's make this cost function exist somewhere else. And let's just try to write it from first principles here. Counter plus equals cost. Compute cost. Okay. Compute cost is gonna say it's the cost. Tomatoes cannot be trusted. That's a good username. Why can't they be trusted? Computing costs from VC VR. No, VR VC. Oh no, my brain. They're up to no good, you know it? Have you ever heard of the movie Attack of the Killer Tomatoes? Wait, computing costs from 1 0 to 0 0? Oh no. Is that why it's wrong? It's trying to do it backwards? It still doesn't make any sense. So how do you compute the costs? This is so annoying. So we have like dr is VR minus VC DC, or VR minus UR UC UR no VC minus UC. These variable names are killing me. If DC greater than 0, then DC divides by itself. Oh wait, no, just if it's not equal to 0, not if it's greater than 0. Wait, shit, but then we lose our negativeness. How do we get just the length of the number? Why is this so annoying? Okay, fine. If it's greater than 0, we do this. If it's less than 0, we do that. I hate everything. Okay. We have the information we need to iterate from UR to UC. And we don't want to include... Okay. This is so overcomplicated. We're going to say UR plus equals DR and UC plus equals DC, while no. While BR is not equal to UR and VC is not equal to UC, we do these things. Cost equals 0. Costs plus equals dist. Dist equals grid VR VC1. Ugh. Huh. Echo cost. 0. Oh, wait, no, this isn't and. This is or. Okay, 125. We're getting somewhere. Let's utilize this compute cost in here. Oh shoot. We need locals for this. VR. Okay, compute cost, URUC, VRVC. Okay. 111. That's a new number. It's not a good number. Why? Why do you hate me? Cost from 0, 0 to 1, 0. 3. Hey, it's computing costs correctly. From 1, 0 to 1, 3. 1, 0, 1, 2, 3. Yes, this would cost 8 to make that move. That's true. But why are you trying to go that way? Why are you going down first? This is sad. It's particularly sad because it's finding a path that's somehow even more expensive than the right answer. If anything, I would expect this to find a path that's like, I don't know. Maybe I wouldn't. Why does it go down? Like you could go to here. Oh, but it would cost 5. I guess this is cheaper than going to 5. But it doesn't just... It's not like... It's not that dumb, right? Wait a minute. No? Okay. Hey. Thank you for the raid. How's it going? How's your stream? We're pretty deep into the awful. I don't even know what I'm doing anymore. Yeah, we're trying to solve this advent of code problem, but I'm just I'm having a bad time, if I'm being totally honest. My cost function works at least. I don't think I have this one. I think we're in trouble. I don't know what is even going wrong anymore. I did a bunch of things and somehow we're further than we were before. Further away from the right answer. Is this shit? I don't know. No, that's not even doing anything. Let's see if this works. Maybe I'm missing something, but my guess is this approach does not address the fact you need to take costly steps sometimes that pay off in the long run. Isn't that the whole point of Dijkstra? That you find the shortest path? like I don't know. It's literally just Dijkstra. Not really. How is this handling the no more than 3 in a row? So I've never tried this with Dijkstra, but I have tried this with A star. The idea, maybe this doesn't work with Dijkstra. But basically, we're only connecting, or we're over connecting the graph. We're adding more edges. I know this can work with A star, but maybe it doesn't work with Dijkstra. I don't know. Even though Dijkstra is pretty much the same thing. Because I've done this with A star before to implement like a kind of like a chess rook movement, and it worked there. So I don't see why it wouldn't work here. If you find a new minimum distance to a node, if you find a new minimum distance to a node, depending on how you entered that node, it might not be able to leave in the same direction. Depending on how you entered that node, it might not be able to leave in the same direction. We're handling that here, right? I get 78 if I let it go in the same direction multiple times. Wait, what? Wait, what? What happened? I commented this out. Oops. Commented this out and now it's 78. I bring it back and it's still 78? Oh, I did. You're right. Thank you. I accidentally hit a button. I was so confused. I don't think this does anything. Just makes it run faster. I guess it doesn't when you time somebody out. I think that's a different message. I don't know. Yeah, or maybe I never deployed. Who knows? We can... I don't know. That gives us 134. Wait, how does that give us a bigger number? Wait. Oh, because we still have this. So we got rid of all of this. This would just be true shortest path. We get 78. I'm not sure what that means. Google's not sure what that means. For example, to get to 1, 3, it thinks the best path is 1, 0 to 1, 3. It's best to take the route of the example because you can keep going forward. So what would the cost be to get to 1, 3 this way? Be 4, 5, 6, 11. But the way it's going, it's also 11. But then it gets better because you can keep going that way. I don't know how else to approach this. Like, I've tried all the things I can think of. What am I tracking for each node? Distance, like the overall running distance, the overall shortest distance we've found so far to get to that node. Right? Maybe we shouldn't, hold on. Maybe we shouldn't do this. Well, that doesn't change anything. Seems to be working, right? Okay, what's different about A star besides the heuristic? Nothing? Nothing. Yeah. So I don't think that really changes anything for correctness. So let me think about this. I don't know. What other ways can we implement the stupid constraint? We can get 78 if we don't use the constraint. I had to track multiple shortest paths per node. Maybe instead of creating more edges, you create more vertices. That would be a lot more vertices, right? Or would it not? How would creating more vertices work? I don't know how to think about that. More vertices. No, I mean, I think there's maybe something there, but like, how many vertices would this become? I don't think it works because it's just like it like explodes infinitely. How's your Bash Dijkstra going? Not well. It works, but we don't know how to implement this constraint. Alex said I had to track multiple shortest paths. How does that work? Multiple shortest paths? I'm cool with hints. I'm pretty clueless when it comes to this.
Fatality.
Like, I tried the one idea I had. What are these ones? That's with negative weights. We don't need negative weights. I feel like adding more edges should work. Maybe not, though. I guess it doesn't work because of that case that we discovered where, like, you can get to here, but or here because this is in the middle of a move. Changes the connected nodes. That's true. Hmm. Yeah. Yeah, treating it as several nodes. We were talking about that, but I'm not totally sure what that means. Like, how many extra nodes would we need? Yes? Okay, we can try it. I'm using Ubuntu. Uh, yeah. That's what I was kind of I was trying to imagine how cuz it turns into like a 3D thing, but I didn't know how deep it would go. I was having trouble thinking about it, but I'll try it. Wait, times 12? Wait, why is it times 12? So you just have one edge per node? Or wait. How does that work? Because doesn't each node have... Okay, wait, let me think about this. So if we're on 2, we can go to... If you enter a node from the left, but you can still move left 1 or 2, changes what connections are possible.
Fatality.
Oh. Oh, wait, that's interesting. Is it interesting? No, I still don't get it. You only need to know what exit nodes are available. Well, wouldn't it be times 4 then? For every node, you have... You have like a layer that's only connected to the... Like if we're moving right, let's like zoom in on this one. So this 3 would become like 4 different 3s. And this would be, since we came from the left, we're only connected to the one that can, well, it's actually 2. From here, we can only go down or up. But we would need 4 variations. I guess we only need 2 variations? Because you can never go back the direction you just came. So you can only go... If you're going vertical, you can only go left, right. And if you're going horizontal, you can only go up, down. So it's 2. So we have like a second layer that's like the vertical layer and the horizontal layer. Is that real? I don't know, let's try it. For D in HV, oh wait, this is no, this is not right. It doesn't go here. It goes up here when we're creating all of our vertices. Oops. Do we want it to be the first thing? Sure, why not? Oh, but would we start at the horizontal one or the vertical one? Suddenly it's confusing. I guess we start at both, right? Like, it doesn't matter. They both have a distance of 0. This is going to break everything. Okay, 0. I don't know. If it's more, we'll add more. uh, me neither. Me neither. Because if you come in from the left, or if you come in from the right, you can only go up or down after that. Is my thought process. I don't know. We can just try it. We're adding a third dimension. We can do whatever we want with it after we refactor to use the third dimension. Yeah, so what are our neighbors? If we're going up, I don't know if this works at all. Wait, what happened to all of our other ones? This isn't changing anything, is it? Well, I mean, it doubles the size of our... Yeah. V equals VL. Did it work? No. Oh, my cost function maybe doesn't work anymore? No, it should. We're 3D cooking. Because the cost doesn't factor into the 3D. Or the 3D doesn't factor into the cost. Oh, wait. I don't know. Where are we going wrong? 0. Shit. We're not finding a path anymore. Uh 105 and 103. Neither of those seem right. They're both pretty close. Ah. Huh. We went... What did we do? We went right 2. Then we went down 1. Then we went right 3. Then we went up 1. Right 3. Down 2. Right 2. Down 2. Right 1. Down 3. Right 1. Down 3. We went left 1. And then we went down 1, right 1. Down 1, right 1. We ended on the wrong cell. We straight up missed. How did we end on the wrong cell? Do we need to push the target to the sequence? But yeah, it did the wrong thing at the very end. It was like I'm gonna go down 3, left 1. Oh no, it did go down 2, and then right 1. Wait, no, this is the right path. Why does it get the wrong number? It's literally the right path. It's just calculating the cost wrong somehow. It's going from wait a minute, what? Oh, what am I doing? 0 blank? Don't know about 0 blank. What the fuck is 0 blank? Oh, wait. Oh. 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 We just had a typo. Okay. This thing needs to do it twice. So we need to cook twice. For layer in HV do done layer 273. Eh? No. 104 27. Huh? Wait. We can talk about this. We can talk about this. It was just working. You were just working. Why have you decided to lie now? What did I change? Something's not getting reset. Or something's getting screwed up. If I change this to VH, we get the same numbers but backwards? No. What the fuck? This is disturbing. This should be just completely, I don't know, local? Okay, can't do that. Was that the issue? Weird. I thought declaring the array again was supposed to clear it. Okay. I was misinformed. Okay. We just pick the smaller of these two numbers. How do we pick a small... Well, whatever. Let's just see what happens. I doubt this is even going to run in a reasonable time. Unset and declare. I really thought declare, if you called it again, it would reset it, but I guess not. Maybe that's only for associative arrays, or maybe I'm just wrong. I don't know if this is ever going to finish for input is one problem. I'll tell you what, I'm going to go to the bathroom and hopefully it's done by the time I get back. This is what I was afraid of. How long does it take to run on the sample? Good question. Oh, wait, that's just running it on the same thing again. Takes 0.4 seconds on the sample. And the sample is how big? 13 by 13? So it's going to take... somewhere in the realm of like... How long is 4,000 seconds an hour? It might take a while. Good enough? This is part 1. What do you mean good enough? I don't know if it'll even run, is the thing. Oh, it's cooking. Like, it might just get stuck. How can you parallel this? The Dockers aren't from... Doesn't bash work well with parallel? Yeah, but like it doesn't mean like every problem is parallelizable. You can't parallelize a problem that has like shared state. It just doesn't work. You're just slowing it down. All right. Is there anything we can optimize? I don't know, really. We're already pretty low on forks. What should we do while we wait? Write a faster bash? We could try it on like 100 by 100, or not 100 by 100. Like a, I don't know, a 20 by 20 grid. Like what happens if we double the sample size? If we like, how do I do this? There. Is that twice as big? We can see how it grows. Ooh, it 20 by 20 is a lot bigger. So if that was what's the scaling factor here? We multiplied by like 12 to double the size of the puzzle. And we need to double how many times? 26, 52, 104. So we need to double it 3 times. Is like multiplying this by 6 times 12 times 12 times 12. That's like 10,000 seconds. Times another like 6 probably. That's like that's too many. That's 17 hours. um Yeah. That's let's see. We have 16 cores, so it's just a bit over an hour. Mm-hmm. Okay, I'll just make it multi-threaded. But I can't because it's already running. So if we make changes to it, we would have to start over. And we can't start over because we're already 10 minutes in. Just live patch the memory with new instructions. All right, all right, all right. We could do that. That's no problem. What if we did A star? What if we add some heuristic function? What would our heuristic function be? Is there any heuristic function that helps? Yeah, we could use well, there was also this, right? After line 10, if u equals target, we can exit. But that won't work because we need to find it for both layers. Okay. So we're sitting at 6 seconds for sample. What happens if we add the target equals h target Did we make it faster or slower? About 0.01 seconds faster. Good, good, good. Very good. All right, I'm thinking that's not the solution we're looking for here. I don't know what to do. This is exactly what I thought was gonna happen. Like, I don't even think we could do the actual shortest path here. Like, even if we just do shortest path, I think it's still gonna be way too long. Unless I put a syntax error in. Do you always stream at this time? It varies. A lot. Yeah, that's not even that much slower. Wait, 146? That's not right, though. Maybe we can memoize our cost function. Wait a minute, why are we getting the wrong answers now? Oh, because it's the bigger grid. Yeah, yeah. Yeah, that's a lot of costs. Uh, key equals URUC VRVC if costs key then cost equals costs key return costs key equals cost. No, we don't make a lot of the same cost calculations. Do we make any? Yeah, we make a few. It doesn't make it any faster. I just don't know. Yeah, I did. It didn't help very much. Am I optimizing or still trying to solve? I mean, both. I don't think we're gonna get it, though. I think it's just too many operations. Thanks for the bits. Mm. I I don't have a lot of ideas left. Code Monkey, you said you did something different, right? As opposed to the like multiple Like the 3D grid. You did A star? Oh, one thing we're not doing. Okay, one thing that is slow is this linear scan. Right? We have to find the smallest distance in the queue because we don't have a heap. Row times column for heuristic. Does that help a lot? Row times column. So you're prioritizing going towards the right corner. This is P1 or P2? This is P1. That makes sense. I think the biggest performance boon we would get is if we had a heap here. We could try a bash heap data structure. Surely somebody's made one. Heap sort in bash. Oh boy. No, no, this is not good. This is slow. Why are they even doing this? What the fuck is the point of this? Do we have to do it ourselves? I don't want to do it myself. Would it be faster if we just shell out to sort every time? $3 difference between heap and sort by for part 1. Oh, it's gonna be so awful. I don't want have to do it. We could try to figure out what the fuck ChatGPT was smoking when it wrote this one. Like, stuff like this is just... that doesn't do anything. You can't do this. Does this even work? Let's just try it as is. Heap. Nice. We NQ 31415 and we get 111. Very curious. Very interesting. That gives me 111 when I run it, which doesn't seem right. Looks like there's a mistake in the comparison function. Oh, that's not where the mistake is. No, you still have the bug. Good try though. I think the bug might be when you try to unset a string. True. There you go. I feel like that's going to be really slow though. Local front. Okay, we're still doing that. I still get 111. Uh-oh. What was the other bug you said you found? Heapify down at a bug. All right. Still doesn't work. You have failed the interview. ChatGPT, I'm sorry. Ah. Still doesn't work, by the way. It appears there was another issue. What do you mean? Oh, okay. This fixes it. Don't worry. This is the fixed version for sure. No. Still getting 111. Seems there was a misunderstanding. Oh, of course. The correct condition should be checking. Oh. That's probably what it is. It's probably not your DQ function. Definitely not that. I don't know of any. I think your DQ might be busted. Oh, there's an issue. What's the issue? That's the same thing I already have, don't I? Yeah, you literally gave me the same thing. What happens if it does work and you tell GPT that it doesn't? Secret access to your ChatGPT competitor? I'm good. I feel like I just need to write it myself. It probably has a lot of the right ideas here, to be honest. Like, let's see what it's doing wrong. Uh... Okay, so it is not sorted. Oh, wait, but it's not supposed to be sorted. That might be right for the heap. I don't know. It's at least in a different order than they were queued in, which is good. So what is DQ doing wrong? I thought this was the right syntax. Is it not? Aren't we doing something similar in ours? To Q? Yeah, it really should work. Is Heapify down, like, doing something dumb? Let's try commenting that out. No, that's not the issue. Is it because it's doing it in a subshell? Oh, okay. It was the example usage that was wrong. Okay, surprisingly, this does work. We need to modify it, though. How do you even do this with a heap, though? Like, how do you associate the thing in the heap with a node? Am I just supposed to put the whole everything in the heap? I guess so, right? It's whatever it's the same as whatever I have in my queue. What's in my queue? I think my queue is the 3D coordinate. So we'll have a 3D coordinate followed by maybe space priority. But then we have to somehow update it when we update the distance. That's the part I don't get. $2,000 to 2,500 elements at most on that queue during part 1. Are you saying that's low or high? And somebody else said it was more, right? Somebody said they had 16k elements. Maybe that's for part 2 though, I don't know. That's part 2. How do we even update it though?
Fatality.
We have to like every time you update it, it's a linear scan through the heap to find. Well, it doesn't have to be. Or is it not an update? Guys. No, because every time it comes off the queue. Yeah, wait, how does this help us at all? Let me read the implementation. Add with priority, decrease priority, and extract min. We don't have a decrease priority function. Okay. Let's make it this be 111 222 333. Okay. We need to cut everything up to the last comma. Yeah, now we got a problem here. Wait, how do we have a problem here? Hmm. Hmm. All right. Shit, still? Yeah, it's Neovim. Hmm. Where's our issue now? Line 60. Oh, right. We need to do this thing for all of these. Oh, we can just do it here. I think. Line 61. Oopsie. Okay. We are still sorting. But we can now store additional data next to our priority, which is good. Um Now I need to be able to decrease the priority of the thing. This is the awkward one. Key. Priority. How do you implement this? Decrease key operation replaces the value of a node with a given key with a lower value. Find the index of the element we want to modify. Decrease the value of the node. Down heapify. But I think it's the opposite because I think we have a min heap. Do we want a min heap or a max heap? What's our priority? We want a min heap for sure. So we heapify up, I think. We just need to find the index of it. How do we find the index? Oh, then we just search. That's dumb. This isn't going to make anything faster then. Break. Priority queue I equals key priority. It does work. This might still be better. I don't know. We have implemented a binary heap. This is insane. So instead of this, we do uh Sabna could make you like Bash more or less. I don't know. I guess it's about the same. I understand that it's not meant for these tasks. We set to 0. We can get rid of these now. Move this comment up here, I guess. Okay. Well, the size of our priority queue. Yes, we're not going to do any of this now. We're going to call DQ and say U equals front. This needs to do a percent comma star. And we don't do this anymore. And then the main thing we need to do is inside of here, we have to say decrease priority to alt. Decrease priority v alt. There's no way this works, right? It explodes. Okay. It ran fast. It exploded many times. What blew up? Does this need this? Is that your problem? It ran a lot faster, but it didn't get the right answer. It got 0. Now why does it get 0? Echo U. Okay, so it is running on things. let's bring it back to our original sample here. No. It doesn't find a path. Is there anything else that's different about this? Interesting. We don't have this in the other one. That didn't help, though. Why does it run so fast but not get anything? Do we know that wait, why are we doing this? Wait, D&D 1. Isn't this wrong now? No, that's just it printing out every node that it like visited. It didn't necessarily like link them. Oh, what? What did I just do? Doesn't this defeat the point of... We don't need this anymore, right? We're looking exclusively at UL. If UL equals H, what do I want to do here? If VL equals L or VL equals R, then we continue. If it's V, then we can't go up or down. What am I doing? These ones don't make sense anymore. 87 and 99? Oh no. Those aren't right. It ran fast. That's good, right? Wait, VL. No, not VL. V. Oh, wait, we just need to check. Oh, this is even easier. If UL equals VL, continue. Fucking phi. 0. Shit. No, wait, that's not true. Wait, why are these... Is it the opposite? No. I don't know. Why not? Okay, what if we just don't do this? Do we find a path? Find 8799. I don't know what 87 is. That seems like a weird made up path. Why can't we find a path anymore? Wait. Is this what we want to do? Do we not want... I'm still not convinced our, like... algorithm is right, but... No, I don't think this is right. What did we have before? We had this. We're just trying shit at this point. Very late or very early? You know, it's just very. It's uh uh it's a hard problem, okay? I don't know how to solve it. It's not working. Wait, is this saying... Are we back to saying that, hold on. This might be something. Oh, these are weird. Huh. Okay, let's bring it back to... Oh, wait a minute. I have an idea. I don't know if it's an idea. I'm too tired. 0000. How? How? What? $94. All right. So what if the 3D coordinate is based on... Hold on, I'm cooking. The 3D coordinate is based on how many steps in that direction you've taken. Hey, Brainoid. So that would mean... let Tim cook. The 3D position... Okay. The thing is, I don't even know if 94 is right. I don't know anymore. So if you're connected in 4 directions, Um, wait, shit. Okay. No, because it needs to be. Okay. Let's think about all the possible moves. If we're at the start, we can move to here, 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 or here, there, or there, right? Wait, what? Here, here, or here. And so if we did move to this one, this one has fewer connections, right? Another ImageMagick solution. This one only has connections to here, here, and there. But if we went to this one, it technically still has a connection. It has that one and all of these ones. But I don't know how that helps clear things up. I'm starting to see what Alex was talking about with the 12. The 12 different like 3D layers. Right? That last one is not going to be a valid solution in any case. Interesting. Well, it's not going backwards. Sorry, I'm saying if we go from 2 to 1, then this one could also decide to go forward to the 3. But that's just dumb, because why do we need to consider that? Because we can already go straight from 2 to 3. I don't get why my solution doesn't work. I'm sad. Where did you implement the constraint that you can only go 3 in a row? Because you said you did it differently than Alex, right? I think I might just be too dumb. Maybe just cross the whole thing out and give up. Let's see if we can even run the input with this. I bet it still doesn't even work with the heap. Store the forward movement on every node in the queue. Store the forward movement on every node. Every node in the queue. So not in the previous, but in the queue. I don't even think we're gonna be able to run this. Like, yeah, like, I think this is hopeless. I think this input is just too big. What happens when I try to run? These have been running for like, this one's been running for an hour and 20 minutes. It's too big of an input. Like, we can't find a shortest path in general, then we can't do anything. You know what I mean? It's just not gonna happen. You mean for the answer, or? Hmm. We could simplify this now. If we're only making one step at a time, hold on. Let me see if this is what's hurting us. Compute cost. We can just say, cost equals grid. Yeah, even without that, it's prohibitively slow. I don't think the priority queue helped us very much. Yeah, I don't think it's gonna happen. Unfortunately. I mean, unless I cheat and use a different language. Hmm. Why am I getting 0 now? Oh, here. Still 0? You sure? Oh, here. 78. If we can get anything to run on the input, I'll be impressed. I mean, normally these are designed so that you can, like, as long as you have a good solution, you can do it in whatever, but this one is like, this is a really big input. Like, maybe if we have a better heuristic, we can get it to go, but I don't know how much saving that's going to give us, right? Like, A-star is like pretty different actually. Because your example result is wrong. Yeah, but I'm not even trying to like find the solution right now. Like right now I'm just trying to solve like shortest path. I can't even get shortest path to run on this. You know? So how am I going to get the right answer if I can't do shortest path? We can try doing A-star instead. Might have better luck. So you start with just uh just one thing, right? Then came from is empty map. Okay. We're going to initialize all of the G scores to big number. Uh, wait, this just terminated. Okay. All right, we have a chance. So you're telling me there's a chance. They both just finished. This one took an hour, 30 minutes. This one took 4 minutes, 58 seconds. I don't think this is correct, but we can try it. I think this is way too small. Why am I just so fucking good at programming? Oh my god. Holy shit, yeah, it was just too easy this whole time. Holy fuck. We are so back. Who is calling my plan flawed? Which one of you was it? Never doubt me again. The code you had before was working fine, slow but fine. Yeah. I am so genuinely surprised. Holy. We fought hard for that star. That star was well earned. All right, how about part 2B? Like, it was probably same thing, right? Crucibles of lava simply aren't large enough to provide an adequate supply of lava to the machine factory parts. Instead, the elves are going to upgrade to ultra crucibles. 1 hour 30 though? Hey, don't. It's not a race. It's a marathon. Ultra crucibles are even more difficult to steer than normal crucibles. Not only do they have trouble going in a straight line, but they also have trouble turning. It needs to move a minimum of 4 blocks before it can turn. Okay, between 4 and 10 blocks. Same thing with 10,000 times the input size. That would be bad. Okay, so 4 to 10 blocks. Let me think about that. It is a much bigger search space. Is it minimum of 4, maximum of 10? So it's 4, 5, 6, 7, 8, 9, 10. 7 when we were previously on 3. That's a lot more edges on our graph. Okay, I think we'll continue down the rabbit hole of trying to implement A star instead of trying to get this to run on our old input. Well, I don't know. Should we start from where we left off? Let it run overnight? We could. I don't even remember what was running in this one. Like, was that when we committed? Progress, I guess? Was this the... Okay, let me... Commit AM IDK. Wait, we have unsaved changes. Yeah, commit AM more IDK. Okay. How do I want to do this? Let's just push and look at it on GitHub. I don't want to lose my Vim undo buffer. Because I genuinely have no idea if we committed or not when we started running part 1. So we initially committed this. No, this is well before we started running it, I think. Because I don't think this was working. Yeah. And then this is after we started running it for sure. It was somewhere before we brought in the queue. It was before I did this caching. Oh boy. I think it was before I added that check. Okay, here I changed it from input and then back to sample, then back to input. This is where we added the layer thing. I think it was right here. I think this is where we ran it. This is the one that worked. This one worked for part 1. Okay. No, it's exactly that point because it was right after I added the layers. The 3D coordinates. Okay. So now we can start bringing back the pieces if we want them. This is their heap. Why is this I think I forgot a Oh wait, what the heck? Oh, this diff is super broken. You've been going for 11 hours straight? Wait, what have you been working on? Or you just mean you've been watching mine for a bunch of time after you did yours? Trying to follow a bash implementation? Yeah, that'll get you. All right, what were we starting on with this this A star? Honestly, we could just adapt this and leave it running. I don't know if it would, like, I don't know how to think about the complexity increase. It's at least twice as many edges. Yeah, fuck it, we'll do A star. Where were we in our implementation of this? G score. I think this is what we had written so far. And we're going to get rid of all of this. It really okay, so I'm starting to understand where the concept of boiling it down to two different layers is, because you really have two different options. Think about this. Your two options are you either go down or you go right at the start. And that dictates your path the whole time. Those really are the only two like things you need to differentiate. I can't speak today. I can give you a hint. My solution needs to walk nodes 32.49x more nodes in P2. What is why would it be? I don't know how that's a hint. Are you just saying like I could, I don't know. But I think I'm starting to understand my own implementation. So that's exciting. Okay, we're gonna get rid of all of this. Oh, how long it could take? Well, it sounds like our solutions were pretty different up until this point. Uh, so this is gonna be interesting. We're still gonna have this thing. Let's do a little Vim. Okay. Then we can do like what? Why did that close Vim? I tried to do a macro and it just closed. Okay. Okay, that time it worked. I don't know what happened the first time. Okay. Oops. My brain is like melting. Oh, that's the wrong one. This one. Why did I type a Y? Okay. Let me do the same thing here. Six at what? Okay. We gotta get rid of the threes. But if we're gonna do it the same way, this is how we're gonna list out all the edges. Jesus. Should be fine. How many edges is that per 28? We should probably have bounds checking, even though it already seems to work without it. I don't know why it seems to work. Let's add explicit bounds checking. If VR less than 0 or VC less than 0, continue. If it's greater than or equal to size, then we also continue. I think we don't have this in A star. Okay, how does A star work? This should honestly just be defined wherever we read size. Okay. So we initialize our G scores. We're missing our outer loop for layer in VH. We've deemed this important. We're definitely going to want to run this on sample. I've been editing the wrong file. It's fine. p2.sh. Yeah, it's got a lot of bugs. Okay, my G scores are looking good. For node n, F score is equal to G score plus H of n. And you were saying your H of n is just row times column? That seems... Seems like it would be too low sometimes, no? Which day? We're on day 17, part 2. It's a real struggle. Our part 1 solution took an hour and a half to run and somehow got the right answer. I'm not questioning it at this point. You finished 7? Been there? Yeah. It definitely works for you as row times column. All right, we'll try it. We can always adjust it. If current equals target a week runtime. I'm scared. Use the wrong algo in Python. Oh, this already happens by DQ. Okay, for each neighbor. So this is our big horrifying loop. Tentative G score. Wait, D takes 2 things? Oh, D is different than H. The weight of the edge from current to neighbor. Yeah. So this is our compute cost function. Uh, URUC VRVC. And then we need the G-score of current. Let's do... Okay, tentative G-score equals G-score U. Tentative G-score plus equals cost. Should probably put this here. If tentative G-score is less than the G-score of the neighbor, okay, that's V in this case. We set came from equal to U. They use Manhattan distance for the heuristic there. Yeah. F-score is plus the heuristic. So this would be VR times VC, potentially. If neighbor not in open set, then we add it to the open set. That's interesting. How do we check if it is or not? I guess we'll just add it to our in-queue logic. In-queue V. And then what's our priority? It's the one with the lowest F score. Oh. Okay, so this would be where we do our decrease priority of V to F score V. So we should just put them all in the set to begin with. like we were doing before, I think. Oh, we're already doing that anyways. Oopsie. Okay, we have some we have some typos around the place. Right, we need this bounds checking. And then we need this stuff. Well, let's keep this out for now. Yeah, this is Neovim. Done. Okay. So we need to do the walk back. This part. Something instead of prev, it's now came from? Hmm. You want to learn Neovim? Is it hard to start? No, there's a bunch of resources. There's like what's it called? What's the like gamified one? There you go. That one's cool. Or Vim Tutor. Could do that. This needs to be in a loop, right? For a level in VH, do done done. Curious. So I didn't find path at all. It's not great. Oh, but we need a new sample, right? I think the default sample does work. Hmm. All right, what do we have wrong here? Well, it would seem we're never getting to this case. Those are some big numbers. But then there's some small ones. Yeah. Our our part 1 solution ran for 90 minutes before it worked. But it got the right answer. So we're trying to optimize a bit so that this one doesn't run for, 10 hours. We used Dijkstra. But now we're trying to switch to A star. Oh, I'm an idiot. Look at this. There's a $sign missing. That didn't change anything. Nice. All right. Well, it's probably not the only one missing. Who even knows if this fucking priority queue works? Let's be real. Day 7? Wait, what was day 7? I don't think I even know. A star? What did you use? Did you use Dijkstra's? Or something else? Wait, how is your day 7 running for so long? It's just sorting. Worked for part 2. Yeah, I feel like we could have adapted our... I think it would have taken like 3 hours to run our part 1 solution on part 2. But it could work. But I wanna get it faster. I don't get why this isn't working. We don't have any options that lead to the exit. For some reason. That's interesting. How do we not ever get to the... That's crazy. This is way too few times for it to print. Day 5? Oh, day 5 was, yeah. Wait, did you just brute force day 5? I think mine would have been running for the rest of time if I did that. Gosh, how do I fix this? What is wrong with it? Does this approach just not work? This is Bash. Chi-Chi, how do you deal with the constraint for part 1? I need help. I'm trying to set up Bash RC when I log into the TT. I don't know. I can't help you with your system. I'm sorry. My day 5 part 2 before ooming. Yeah, the 1 to 3 spaces. How do you? Because the way we're doing it is like by like over connecting the graph. We do this. We say like this one is connected to all of these different edges. Your position is XY direction. Gotcha. And then you just do like you look back like what, like 3. See, I tried doing that. Maybe I didn't try doing that. I think I didn't exactly try that. So you have like 4 times as many nodes as you have like 4 different 3-dimensional coordinates. Okay. For mine, I only have 2, but I had a lot more edges. Yeah, I'm not doing just XY, but I only have 2 3D coordinates. I have vertical or horizontal. You would think. So it sounds like we're doing basically the same thing. I mean, it did work for part 1. That's where I'm at. I kind of want to like write it in a faster language just to verify my solution. But I also don't want to do that at all. Oh wait, do I need to re-enqueue this thing? Wait, so how does this shit work? Add V. No, but V should still be in the. Okay, maybe decrease priority needs to do an enqueue if it found equals false. Found equals true. If we didn't no wait, if we didn't find it, we enqueue it. Wait, we want to flip this. I don't think that changed anything. I don't trust this priority queue at all. It really could be breaking everything and I wouldn't have any idea. Let's do some testing on it. Hey, my idea works. Nice. um all right, let's yoink all this. And go back to heap.sh. Oop. No. Don't do that to me. Okay. Thanks for the follow. I'm still awake. E, B, D. That's what we expect. E, B, D. Yeah. Sure does work all the way. What if we do an in queue like in the middle? NQ G 9 comes out last. It sure seems like it works. Like I'm going crazy. So this is weird. We're not supposed to start with everything in the queue. So I guess we aren't supposed to do that. We still never make it to 1212. How? Wait, 00. Wait, what? Oh, we're not doing that anymore, or are we? Oh, what the fuck? My first world problem, it's irritating when my earbuds start to slip and I push them back on and Bowen's Bad Cop stream. Hey, Alka. Did you solve day 17? I'm on the struggle bus. You noped out? I should have noped out. But here we are. I don't even know what this is printing at this point. What does it think the target is here? 4-4. Neither of the dimensions are 4. Oh, I see the problem now. We assume a square, and this example is not a square. Um, height. Width equals I don't know. Height width equals grid 0. The length of that. Target 411. Okay. That's better. Where are we using size? Height. Width. Hey, how's it going? Yeah, it has been a while. Alright, something happened. I don't really understand what happened here. So we still have empty spaces? I guess that's fine. Yeah, so it went... Okay, let's see. It found 2 paths. Let's grab our counter code from before. That doesn't seem right. 3? Oh, wait, this isn't the right counter code. Compute cost UC URUC VRVC. Prev equals target. UL URUC from prev equals sal. Uh-oh. 92 and I don't know because it crashed. It's 92 even, right? 71. Can you defeat your own champion fish? Yeah, you can. We're getting stuck in compute cost. We are. From 411 to 04. Oh, that's not a thing you can compute. What the heck? Is this just supposed to be 00? You're telling me you solved it in 15 costs. I don't know if I believe you. What did you do? You went from 00 to 04? Uh-huh. Oh, you broke the rule. You cheated. Yeah, you cheated. Okay. All right. It makes sense that it can win if it cheats. Right. I forgot that it was still allowed to cheat, okay? So we have to say if UL isn't it literally this? If UL equals VL, this didn't work before. Then continue. Nope. Nope. Why is that? V and V. Oh wait, did that work? Hold on. 71 and 0? 71, right? Oh, 71 is right. All right. Who's feeling brave? Let's go to regular sample. 0, 0. Fuck. It doesn't work on the regular sample anymore. It doesn't find a path. I know. But why? But why? Why not? What's your target? 12, 12. Why do we never get to 12, 12? Okay, what if we set our F score to be the same as our G score? No, we still don't get anywhere. But why? We don't even find a solution if we take all of our shortcuts out, which is super weird. Like, it should definitely find a solution. Where are all these blank lines? Probably where I meant to print that. What a helpful output I've made. Maybe we're not supposed to decrease the priority? That doesn't work either. Wait, that worked. 94? 94? 94? Hold on. We are cooking. Turns out reading the directions, kind of important. Done. I don't know if we want this. I don't think we want that. What else is echoing? You. Okay. This is going to work first try. Hey, how's it going? Input. Let it cook. We are gonna be here for some time. Wait, should we try it on sample 2 first, just to make sure I didn't break it? Sample 2? 71? Yeah, yeah, yeah. Yeah, yeah, yeah.
Fatality.
It's gonna work. It has it target locked. Oh, we're cooking. Don't even worry. Should we have it print like how far along it is? We could have it print every now and then. What time do you think it'll take? Wait a minute. This isn't with a heuristic. This is with a really bad heuristic. Hold on. That was just Dijkstra's. Does it still work if it's not just Dijkstra's? Okay. Yes. Okay. What do we think a better heuristic might be for A star? What time do you think it'll take? Last time it took 93 minutes. I'm hoping for less, but it could take more. We could try switching this back to the part 1 solution and see. We could race them against each other, right? Part 1 was almost instant this time, though. Well, we didn't try part 1. Part 1 would be like this. It would be like... Wait. Oh, God. This is the dumb way to do it. What's the right way to do this? I guess I could just do 3. 3. So this is what our part 1 solution would be. AOC day 17. What did I do wrong? Oh, I ran part 1. So using A star, we can run. This will be part 1, and this will be part 2. So we need to kill like 90 minutes. Honestly, in 90 minutes, I could probably just rewrite this in JavaScript and get it my answer. That's the sad part. That's the truly unfortunate part. 90 minutes, do it by hand? Whoa. Do it by hand. How doable is it by hand? I think by hand it would be really, really hard, actually. Yeah. You could maybe find a path, but finding the best path is going to be very hard. Yeah. I was trying to think like maybe if it was colored, like if you assigned colors to the different numbers, then maybe you could like see the path a little better, but even then it's like it's pretty bad. Have the original program spit out X, Y, VH dist anytime the value is updated. Uh oh, that's not a bad idea. Here, we'll get another. We have enough cores. Uh let's fix this. Bring this back to what it was for part 2. Okay. So you mean every time we hit the G score, this one, we can echo uh what did you want me to print? The row column. Sure does update a lot. Why do we even have this anymore? Thanks for the follow. Yeah, I don't know what I'm gonna do with this information. Like, I don't know. There's a lot of output. I can hear the fan spinning on my server. Just print if x, y within 10 by 10. Just like the top left quadrant. If VR less than... Oh wait, this one finished. 7 minutes? 7 minutes for our part 1 solution after optimization. From 90. Alright, A-star is based. Yeah. If VR less than 10 or and let's go 20. I like 20. VC less than 20, then we do the thingy. Right? No, it still prints a lot. But less and less. I still don't know how I'm going to validate these values. But I think... I think we just let it run. By hand? No. This should only take... I don't know. How much longer should it take than part 1? We've increased the neighbor count by roughly double. Yeah. But what does that mean? Like, okay, if this took 409 seconds, how long would it take for us to do one where it's just like 1 in each direction? Right? That would be 3 times less branching. Oh, hold on. Let's get rid of that echo. Like let's see how the time scales with this. This should take some multiple less than 7 minutes. But it's probably like exponential from there. We can plot some data. Okay, we've been running this one for 14 minutes and this one for 1 minute. The fan is really going. No. Yeah, my computer is like this right now. Hey, how's it going? I'm a child. Okay, this one ran in, I didn't time it, but a minute 47. So if we think about numbers, what is a minute 47? Um Okay, no. Hold on. Let me cook. We're gonna figure this out scientifically. Uh uh Wolfram Alpha. Okay, fit a curve to 1 107 uh 3 7 times 60 is 420 plus 35 is 455. But then also let's run it with 2. And this should tell us what our curve looks like if we have 3 points. Oh wait, shit. Time. Oh, and 0, 0. Yeah. Probably. But I want one more data point. 2 comma something. So we can really see the the growth. It should take less than 7 minutes, hopefully. I'm guessing it'll take like 3. Maybe it's linear. Maybe we're fine. I don't know why it would be linear, but you know, you can hope. This one, yeah, it would be very weird if this was suddenly longer. I agree. We should implement a thing that's like a fish summary at the end of every stream. It just scrolls by all the fish really fast. Mathroom is still at the top of the leaderboard by a good margin. Although Flops has a great fish here. Yeah, we're gonna have more fish stuff, don't worry. The fish stuff is a mainstay. All right. If you could hurry up and finish, that would be great. Because as it stands, this curve is not going to make any sense. I feel like this curve already doesn't make sense. Is there a Hall of Fame for people with completed fish stacks? There is... No. There should be. That's a good point. There's just overall fish caught. There's this. All right, this curve officially doesn't make sense. So I'm confused. I guess the heuristics probably messing things up. Oh, it finished. Okay. 4 times 60 is 240. 247 seconds. 247 seconds. Here we go. Huh? Wolfram Alpha did not understand the assignment. Huh? It's not x squared. Okay. How do we get it to do this? Wolfram Alpha fit a curve to points. Curve fitting. Oh, linear fit. Okay. No, I want like a, yeah. Maybe a quadratic. Okay. solve for x equals 7. It thinks it'll take 30 minutes. Wolfram Alpha's betting 30 minutes. We're at 24. All right. Who feels like gambling? Never mind. It's done. It finished. No gambling. If this isn't the right answer, I'm turning off stream and you'll never see me again. So, good thing that was the right answer. Holy shit. I can't believe the things that we have done to get here. And I'm scared for our future. It only takes 24 minutes, Pog. Let's fix up our part 1 solution. Oh wait, shit. That was the wrong thing that I just committed. It's fine. We can fix it. I think this is the one that works. Yeah. Okay, and then let's copy our part 2 to part 1. And we'll just fix this up real quick. Oops. Okay. I think we're good now. Optimize part 1 to also use A star. Whew. What a ride. So that was another 7-hour day. That's gonna be fun to record or to edit. Yeah, I hope they don't make it harder than that. Please, please. I mean, harder is one thing. I hope they don't make it so that it takes that long to run again. Is the main thing that I would appreciate. That was ridiculous runtime. Just edit out the bad parts. Yeah, this will be my shortest video yet. I'm just gonna edit it down to like 3 minutes, and it's just gonna be like, oh yeah, we just do A star, and then okay, it's done. Can't believe we wrote a fucking heap. Aren't all of the AOC solutions supposed to be computable within like 5 minutes? You know, I think they just weren't factoring in bash into that calculation this time. We got left behind here. Oh, we can clean this up some more. Here, let's change this to say like a good neighbor, because that's funny. And you have to have a funny comment in your code, not a serious one. It's important. We can get rid of this. We can get rid of this. We can get rid of our pseudocode. Find solutions. Five minutes in dream time. Delete ChatGPT's comment. Who put so many comments in here? All right. Uh, do A star pathfinding. Okay, do the same cleanup in here. Or honestly, let's just do this. Let's do don't need comments to be recorded doing it. Exactly. Let's just copy the one thing that's different. And then we can copy P1 to P2. And we can paste that. Delete this and we're good. Clean up time. All right, how did we do? 228 lines. That might be one of our longest solutions yet. That's wild. We can also get rid of this stupid heap. Get rid of ChatGPT's terrible heap. Pain. Suffering. Do you remember back when it was day one and this was the solution? Does anybody else yearn for day one again? I hated day one when I was there, but now that I'm here, I just want day one back. Later days tend to be easier, like the last few, or what? Very later. For some reason, I was looking at if I've ever done it before. How do I get to it? Events. For some reason, I did in 2020. I decided to do days 1, 2, 3, and 19. I have no recollection of doing this. Very sequential. This one looks like a mess. I don't know, weird. How did we do? Come on, Alka, get it together. Okay, 12 hours. But our delta time was only... Hey, this is pretty impressive if you think about it, from the fact that our delta time was basically the runtime of our P1 solution. So we could have just ran... No, not even. Because P2 would have taken longer. So we did faster than the naive solution, including our runtime. That's pretty good. Although it's because we were halfway through writing the solution to part 2 when our part 1 finished. Which was such a huge surprise that it even finished. I thought it was just going to run forever. All right, I'm happy with that. Who's advent of coding? Jeff Irwin? Y'all are smart peeps. When I open the mobile app on my phone, I have an iPhone. Why does Twitch's app tank the battery life? I know why. It's because the Twitch app is really bad. Yeah. Yeah, there's not much you could do about that. I think there might be third-party Twitch apps that aren't as bad. But for sure the Twitch one is just not good. Yeah, no, it's not. It's not meant to be, it's not designed to be used. So that's like the one downside, I would say. Anybody doing Advent of Code? Advent of Code in Go? I bet they're gonna have a better time. How long has Jeff been going?
Like, Dijkstra should auto. So...
Okay, let's go here. He just said Dijkstra, so we know he's at least got that much. I'll see you all again tomorrow. Thanks for another fun Advent of Code stream. And thank you for all the help, because oh my god, I was losing my mind today.